right, good morning everyone. Welcome. It's always a little bit more empty on the second day than it is on the first. Not sure about this correlation. Okay, there's so many ways to introduce Matt. I decided to go with one that we have, of course, like some internal knowledge base, and if you want to get started with Microsoft and Windows security, this is one of our sources that is listed there. So I'm really looking forward to get some hands-on experiences, especially. Let's welcome Matt.
Thank you. Can you guys hear me in the back? So how many people ran the 10K this morning? A few? That's pretty good. Well, I appreciate you first going to dinner, probably having too many drinks, running the 10K, and then showing up early to my talk. So my talk is titled Subverting Trust in Windows. This is the hands-on edition. I've given two other variants of this talk in the past, where it's more or less death by PowerPoint. So I want to try to limit the amount of slides that I go over, and this is going to be very hands-on, demo-driven. I've got two attacks that I want to show you today, and they're going to be all very manually driven, and so I hope the concepts will really click with you after that. So I feel pretty confident that the demo gods will please me, so fingers crossed, and pray for me. So my name is Matt Graber. I'm a security researcher at Spectre Ops. So let's get right into it. So what is trust in the context of specifically software? So trust means a lot of things to a lot of different people. There are different people will have different definitions for it, especially depending upon the organization and your maturity level. So what are some of the questions that one might ask yourself in the context of software? Like, what software would be worthy of your trust? So here are some of the questions that might be posed. First of all, is this software that potentially has a legitimate business need to be run in my enterprise? Does the software come from a reputable vendor? So what do I mean by a reputable vendor? Again, this is a very subjective term. So reputable could mean, well, it's just a well-known company. They've been around for a while. I think we might all agree that Microsoft or Google are reputable vendors. They're not known for distributing signed malware, at least overtly malicious malware. I guess you could argue that like abusable programs could have some varying intent, like PowerShell, for example. What is the intent of the software? Is the software that we need to improve in our enterprise, is it overtly malicious? Hopefully not. Does the software do what it claims to do, or is it otherwise subversive? That's what we want to determine. Is the software not subversive, and does it do what it is advertised to do and nothing else, hopefully? Can it be abused in any way? So you could have a signed, trusted application from a reputable vendor that attackers will love to abuse. So I've already mentioned PowerShell. People like myself, Matt Nelson, one of my coworkers, Casey Smith, a former coworker of mine, who I spoke with last year, and many others in the industry now love hunting for abusable signed applications for multiple reasons. One of my motivators is oftentimes a lot of these abusable applications can be used to bypass application whitelisting. Other times they can just be used in like clever ways for like a really effective post-exploitation tradecraft, where EDR vendors and antivirus vendors are constantly playing catch up with needing to detect these new abusable, as Casey puts it, misplaced trust binaries. So this could be a factor in the level of trust or lack thereof in your particular organization for a piece of code that you're assessing. So again, like, is PowerShell necessary in your environment? If it is, then there are additional mitigations that can be placed to lock it down. what is the protection status of the signing keys? So this is probably something that's not considered terribly too often because I think people just implicitly trust, in the case of Microsoft, that all of the certificate issuers have pretty good control over their signing keys for when they issue certificates, and that software originating from reputable vendors also maintain positive control of their signing keys. Now, that assumption has been breached in several occasions, and I'll mention a few of them in a few slides. And is the certificate issuer a reputable issuer? Again, we can look to Microsoft and just trust that they have a very stringent policy for getting their root CAs and intermediate CAs included in box in Windows, right? So, but are there any certificate issuers that might be less stringent upon issuing certificates? So maybe they don't validate your, if you're getting a personal code signing certificate, they don't actually look at your driver's license or your passport. Or if you're a business wanting to get like an extended validation certificate, what is the level of scrutiny that they place on you and your organization to issue that code signing certificate? Because as an attacker, if I could go to some weaker issuer where I could claim to be Google and they issue me a certificate where the subject name is Google Inc., well, then obviously that's a big problem. And then finally, is the OS validating signer origin and code integrity properly? This is another one where I think it's just generally implicitly assumed that the operating system has a robust implementation for code signing and certificate validation. And so I'm going, the focus of the two attacks that I'm going to talk about will really focus on this last bullet, sort of subverting that trust and what the operating system does to validate certificates and digital signatures. Now, I think you can map trust maturity in sort of like in the Maslow's hierarchy here. And on the same page, for each maturity level, I believe that there's a respective product that could match that specific trust maturity that you or your organization has. So at the bottom of the period is basically the blind faith level of trust. So I'm sure we've heard from, the hardcore Linux neckbeards that they're like, Linux is just inherently more secure than Windows. I don't need to supply any other justification. Windows is malware. Linux is more secure. Like, just trust me here, right? So, and then, another claim could be made. I actually saw this recently on Twitter where people are like, I haven't been infected yet, so I'm probably fine. Like, I practice safe clicking practices. I'm generally pretty mindful of safe browsing practices, whatnot. So at a trust enforcement level, there's really nothing to protect you in the blind faith level of maturity other than maybe prayer. And then higher up in the chain of trust maturity would be that you have trust in some smart people, right? So you walk the halls of RSA or Black Hat, and there's a million different products from presumably developed by some pretty smart engineers who know what they're talking about. So you trust that you're basically going to allow anything to run by default in your organization unless it's known bad or unknown bad. And that's sort of the unknown bad case. That's sort of where you place that trust in that third-party vendor that they're going to be able to catch something that doesn't have like a known static signature. And so I think your antivirus and your EPP vendors sort of fall in this enforcement level in the trust maturity hierarchy. Now, as we go up and get some more scrutiny in our level of trust, perhaps we only want to permit high reputation code from executing in our environment. So this could be a combination of both just saying, for example, blanket allow anything signed by Microsoft, and then any non-Microsoft, if it's signed, is it of high reputation. Now there's a level of trust that you need to place on the respective vendor who is actually making that reputation assessment, right? So the product that would be associated with this would be your typical like application control products. So these are often confused with application whitelisting, which is a little more stringent. So application control typically involves a level of allowing code to run that is of high reputation and then blocking everything else. And then at the highest level of trust maturity, we would only required software would be allowed to run, and any software that needs to be run in our enterprise has to go through some approval process, right? So maybe you would take each program that needs to run in your environment, run it through a sandbox, run it through your AV, run some like static analysis tools on it, whatever your process may be for that. There is a formalized process in place, and you only allow exactly what needs to be run in your environment. And so this is what application whitelisting solutions can offer. Now there is even one more hypothetical ring to the pyramid here. This is sort of like a mythical level of trust where only what is absolutely required for like business line applications to run and the operating system can run and nothing else. So the most realistic scenario in the highest rung here is to be like, just allow everything that's signed by Microsoft to run. Like I implicitly trust that. There may be some like abusable apps in there, but you know what? Like people are pretty active on Twitter about identifying these, so I can just block those as they come about. But what about all the unknown abusable binaries? You know, there's going to be many, many more that are going to surface in the future, and you're not accounting for those even in this highest rung of the hierarchy here. And application whitelisting can help you in that like mythical level as well. Not all solutions, Device Guard actually can, but it's really difficult to configure and it doesn't exactly scale. So what is the intended purpose of code signing? Really, it's just two things and only two things. It's an attestation of origin. So if something is signed by Microsoft, you trust that that code signed originated from Microsoft Corporation and not some malware author, right? So this is as far as the attestation of origin is concerned, this is where you place your trust in the protection of the signing keys. In this case, we trust that Microsoft has, you know, very good positive control of their signing keys, which I certainly hope they do. And then attestation of integrity. So for any given file or blob, whatever portions of the file or blob are calculated as part of the digital signature, validate that those have not changed. And if they have, then supply some warning to the user, which actually doesn't ever happen in reality, which is kind of sad. So code signing is not, repeat, not an attestation of trust or intent. I know all of you probably know this, but this is a pretty common misconception, even amongst a lot of defenders or like SOC analysts, where they see something that claims to be signed by Microsoft or signed by Google, and you know they just move on. And to an extent, it's a kind of a reasonable thing to do. You know, when you have millions of events pouring in every day, and you need to find that needle in the haystack, the first thing that is reasonable to do probably is to just say, don't show me anything signed by Microsoft. And then I can triage everything that's not signed or not approved, not specifically approved in our environment, and I can triage accordingly. But code signing can, however, be used as an enforcement mechanism for previously established trust. So this is by and large how application whitelisting solutions work. If there is a software vendor that you have determined to be trustworthy, then you can whitelist by publisher and various combinations thereof, including like you could mix like publisher reputation with like file metadata that's included as part of like the signable content in a file. So you can get very specific here. But code signing in reality, I feel as though there are many naive assumptions made by defenders, which I've already alluded to, where if something is signed or some tool that reports the signature status of a binary, it says it's signed, so it says it's valid, so integrity box, check. Origin comes from Microsoft, check, okay? So it's probably fine. It's not one of those like abusable binaries. It's not like WinDBG, MS Build, PowerShell, so I don't have to worry about it. It's fine. And there's a lot of naive assumptions made by many security products. Again, we'll look at some examples in a little bit, but one example would be like SIGCheck. SIGCheck kernel32.dll, it is signed, it's valid, so integrity, check, and it comes from Microsoft, check. Okay, we're good. I've already mentioned this. So in the case where, say, the integrity check does not pass, is a user ever going to be prompted about this? In the case of Windows, no. It's kind of silly, in my opinion, that when one of the core intents of code signing fails, which is that integrity check, nothing happens. You still execute it just fine, and the user is not alerted. There's no log to indicate that there was this hash mismatch that occurred. Whereas if you were to browse on Chrome to some site with a certificate that where its integrity check had failed or the certificate had been revoked, obviously like you're going to get all these like bright red prompts indicating like, do not go to this website, this is not safe. But the same is not true for signed code. And then you have the problem where just many legitimate, a lot of legitimate software from vendors, it's just not signed. So then you don't get the attestation of integrity and origin. So it's really on you as the smart, higher level tier SOC analyst or reverse engineer, assuming you have a mature software review process to validate that this is, that the intent of this unsigned legitimate software is actually good. So let's test some of our assumptions as defenders here. Now assume that we get thousands or millions of events coming in every day, and we need to triage which ones are important to us. So here's some of the text from Sysmon image load event, which as of the later versions does surface signature information, which is kind of handy. Does anyone want to speak up and tell me if there's anything that looks out of the ordinary here? Sorry? The SHA-1? Maybe. So there would have to be an additional check to, like virus total or some like threat reputation feed to validate that hash, right? So yeah, we could check that. So that's a good call. Anything else? Okay, yeah. So the file path is kind of weird. See Windows tasks notepad.exe. So normally the legitimate notepad would run out of system32, right? Now, as humans, like, and like mature analysts, like that file path stands out to us pretty well. But does that scale? Does that level of analysis and intuition really scale when you have millions of events? Not exactly. So what the naive approach to do would be, well, just ignore everything that's signed by Microsoft unless it's one of those like known abusable binaries, right? So this might go unchecked. Auto runs. So it turns out Notepad has, for whatever reason, has been persisted to the run key. You can get signer information as well in auto runs. And one of the really unfortunate things that I've seen a lot of SOCs do is they will just, like they'll automate auto runs like at scale, have it be ingested into like a Splunk database, and they will hide the Microsoft entries because it's just too much data. So, I mean, reasonable, unreasonable, it's hard for me to say, but these are the kinds of behaviors that me as an attacker, I'm going to try to take advantage of. And sysinternals, we know this to be sort of one of the canonical signature validation utilities. The output is pretty simple. There's a lot of switches which can give you more information. But really, as a defender, what you're going to be interested in is, does it pass the integrity and origin check? And so these are highlighted here, verified, yep, signed, notepad, yep, comes from Microsoft. Everything kind of checks out here, except maybe the path is kind of weird. So it turns out C-Windows Tasks is one of a handful of directories within the Windows directory that's world writable. So what are the attacker's goals specifically as it relates to code signing? I've already alluded to some of these. Really the number one goal is to subvert any pre-established trust that may have been placed in a binary or a signer or a company. So cases where this happened recently is in the crap cleaner program and also the MEDoc program, which I think came out of Ukraine, is that right? Yeah. So here are cases where attackers compromise the key signing infrastructure of these companies, and they distributed their own malicious signed updates using the code signing certificates, the compromised keys for those code signing certificates. So a complete subversion of trust, which even if you're using a very strong application whitelisting policy, if these were required business line applications, well, you're kind of screwed in those cases because you've already approved them by publisher and the publisher signing keys were compromised. Another goal is to evade detection. And we've already seen some cases, in the sysinternals examples that I showed, where this would evade and really sort of exploit traditional defender mindsets. And to also circumvent application whitelisting. All right, so here's the first attack that we're going to go over. We're going to hijack a subject interface package, or I'll call it a SIP for short. So SIPs, this is the user mode infrastructure in Windows that performs both signing and signature retrieval and signature validation. And it turns out that all of this is hijackable as an administrator. So the way this works is a subject interface package is just a DLL that has a certain set of export functions that perform signing operations. And there are going to be different DLLs that perform these operations depending upon the signable file type. So there's a SIP for portable executables. There's a SIP for catalog files. Does anyone know what a catalog file is? Oh, okay. Yeah. A catalog file is basically a list of hashes that is signed. So there's I don't know how many, there's probably like over 1,000 built-in catalog files in Windows. So it's another means to perform code signing if a file does not have an embedded authentic code signature. PowerShell has its own SIP. You can sign PowerShell code just fine. The Windows script host, VBScript, JScript, those files can be signed as well, catalog files, and etc. There's several other SIPs. Okay, so all user mode code signing validation, by and large, is performed through the winVerifyTrust function in wintrust.dll. And this is done for a good reason, mainly because the SIP infrastructure is designed to be extensible. So let's say in the future there's some new file type that Microsoft would like to have support signing. Well, then you can just add a new SIP to it, and then everything will be abstracted away from any vendor performing signature validation because all they need to call is winVerifyTrust, basically supply the file path to what they want to validate, and then it will give you the thumbs up, thumbs down if it's valid or not. So here is the implementation for the portable executable SIP in user mode. And all of these are stored in the registry under specific GUIDs. So the GUID that you see highlighted here is specific to portable executables. And this is all of the functionality that this particular SIP implements. And every SIP has a minimum set of requirements that it has to implement. The one that we are going to be focused on today is crypt-SIP DLL verify indirect data. So when you call win verify trust on a file, one of the first things it'll do is it will call DLL get signed data message, which is saying, hey, give me the embedded signature, or if there's not an embedded signature, go to see if there's a respective catalog file entry, and give me that signature. Once you give me that signature, then I'm going to check the signed hash in the signature against the calculated hash of the file that you've supplied. And depending upon the SIP, the calculated hash for a PE file is going to be different than the calculated hash for a PowerShell script. And so that's why for PEs, this function has to be implemented. This is where the hash calculation is performed and ultimately validated against the signed hash. Now, here's how the function is implemented. It's relatively simple, but this generally is not, this is not going to be exposed to like third-party developers, but it's still documented somewhat, which is nice. But basically, it takes two arguments. We won't really worry about what is supplied in those arguments. But what was interesting to me initially when I started doing this research was, okay, so this is called in the SIP, and then it ultimately returns a true or false. I think it's a safe assumption to say that if it returns true, then you've passed all the checks, right? So it's easy enough to test. You can just implement your own SIP where it doesn't do anything with the parameters or the arguments passed in and just returns true. So compile that, go hijack it as an admin, and re-implement you're re-implementing the crypt-SIP DLL verify indirect data function, and what you would get is hopefully that something that has a signature applied to it where its integrity would have been invalidated would then be validated. Now, I'm generally not a big fan of dropping unsigned PEs to disk if I can avoid it. There's also kind of a chicken and the egg problem where if like you're dropping an unsigned DLL that performs hash validation for PEs in an application whitelisting scenario, it's kind of a weird scenario there. So I thought to myself, like, could I possibly avoid this dropping my own DLL that would hijack the verification function? And sure enough, I could. So I was just browsing through in IDA a bunch of exports, because that's all you need to do in the registry is like you point the DLL verification function to the DLL path and the exported function name that implements the verification function. So I looked for an exported function in signed Microsoft code that takes two arguments, basically does nothing to the arguments, like doesn't overwrite any of the pointers supplied to it, so minimal to no side effects, and returns the equivalent of true. And the first one that I found was the dbgui continue export function and ntdll. There's going to be a whole host of other candidates, code reuse gadgets like this. This was the first one that I found, so it's the one that kind of stuck with me. All right, so should be the fun part here. We're going to perform this attack. We have two programs here. We're going to work with Hello World 1, which is just simple Hello World program, .NET program. It is not signed, but we are going to effectively sign it by Microsoft. Okay, so first step, well, let's just go ahead and let's identify the digital signature that we want to apply to hello world 1.exe. So I would like to apply the signature of kernel 32 to hello world. Okay, so let's look at the signature here. I'm using get authenticode signature. And what I'm ultimately interested in is a few things. The thumbprint value. The thumbprint is the SHA-1 hash of the certificate. And with most signed code, there's going to be a certificate chain. So there'll be the leaf certificate at the bottom, which is what was actually used to sign the code. And then there will likely be an intermediate certificate and then the root certificate. I'm interested in the signer certificate. Well, I'm interested in the whole chain. But if I am to validate that I am having a 100% match of the signature in hello world 1 to kernel 32, then I'm going to go off the thumbprint value here. Okay. Another thing worth noting is the status is valid, signature verified, and the signature type in this case is catalog. Now, take note of that because there's a few things going on here. So here's kernel 32, the legitimate one. And when you right click, go to properties of any signed file, and you see the digital signature tab, that means that it has an embedded authenticode signature in the file itself. I've heard a bunch of people say, hey, what the hell? I'm looking at notepad.exe here, and there's no digital signature tab. What the hell, Microsoft? Like, why don't you sign your shit? Well, it probably is signed, but it's probably catalog signed. So notepad.exe, as an example, does not have an embedded authenticode signature in it. Rather, the hash, the authenticode hash of notepad.exe is stored in a catalog file, which is signed by Microsoft. That .cat file has the embedded authenticode signature in it. And the service that is required to do catalog validation is the cryptography service. It's a crypt SVC. So it would be kind of interesting if you were to disable crypt SVC, if that might throw off some security vendors where all of a sudden the vast majority of the Windows OS code is no longer signed. Okay. Now let's also look at the signature in SigCheck as well, just for comparison. Now, sorry, let's go back here. Let's look at the thumbprint that was reported by get authenticode signature, so 1459, and the one reported by SigCheck, 6CAD. So what's with the discrepancy here? So it turns out that SigCheck will default to pulling the signature, will default to pulling an embedded authenticode signature. So kernel 32 has an embedded authenticode signature. SigCheck will be like, hey, here's a signature here. That's what I'm going to validate. Get authenticode signature in PowerShell, it defaults to looking up catalog signatures first. So to the uninitiated, that would be a very confusing thing to see. So now as an attacker, I have to ask myself, which certificate do I want to clone? Do I want to clone the embedded authenticode signature, or do I want to clone the catalog signature? I can do both. There's really no specific rhyme or reason why I might choose one over the other. One consideration that I would have as an attacker would be, is the file Windows signed? And so if something is Windows signed in get authenticode signature, it would show that is OS binary would return true. And when something is Windows signed, basically the only difference between like a regular Microsoft code signing cert and a Windows, and when something is Windows signed is there's an enhanced key usage value, an OID, that just says, well, I can show you here actually. View certificates, you go to details, enhanced key usage, and if it has Windows system component verification, that OID in it, then that is like an in-box Windows signed binary. All right. So let's move on. I have decided that I want to apply the catalog signature to hello world1.exe. So let's go ahead and do that. Now what I need to find is the respective catalog file for kernel 32. Only the problem is that SIGCheck doesn't want to tell me what it is because it's defaulting to the Authenticode signature. So there's a dumb hack that I'll do. When something has an embedded Authenticode signature in the PE, within the PE file format, in the image data directory table, in the security directory, will be a virtual address and a size. So it turns out that this is the only directory in the PE that is not an RVA, a relative virtual address. It's actually a file offset. So this is the file offset to the signature blob in kernel 32. And this is the size of said blob. Now let me copy the file offset. And now what I'm going to do is I'm going to clear this out. Oops. Clear that out. Go to my offset where the signature blob is. And the signature blobs will always be at the end of the PE. Should always be at the end of the PE. Okay, so I have stripped the embedded Authenticode signature from the kernel 32 that I copied. And if I do SIGCheck on the stripped file, it is still signed. The embedded Authenticode signature blob and the offset in size is not calculated as part of the signature. So that's why I can remove those fields and blobs from the PE, and it still validates just fine. So now when I run SIGCheck on it, it has no embedded Authenticode signature, so then it falls back to catalog validation, where it shows me the respective catalog file where kernel 32 has a signed hash. All right, so I'm going to work with that. And I've copied that catalog file locally. And now what I want to do is get the size of the catalog blob. Okay. I want to get that in hex. So we are going to manually construct a embedded Authenticode signature blob using the catalog file itself as that blob. Okay, so we need to note the size of the catalog file, which we're going to stuff into the Hello World 1 executable. When there's the file offset that goes to the Authenticode signature blob, it's a simple structure that's required to be there. It's the win certificate structure. So the first D word is the total size of that blob. The second word is the W revision field, which is going to be the value 2, which refers to win certificate revision 2. And then hex 200 for the certificate type, which just says this is a signed blob that follows. And then the blob follows. In this case, it'll be the catalog blob. Okay, so let's look at the signature of Hello World 1. So it should not be signed right now. And here's what we're going to do. So I have already kind of pre-calculated the header from my win certificate blob. Again, this is the size of the blob, certificate revision, and certificate type here. So now let's manually craft our signature. And the first thing I'm going to do is go to the security directory, and I need to specify the size of the whole blob. Okay. Okay. Oh, I am wrong. That's, okay, size of the blob there. And the offset to the blob, which in hello world 1.exe is going to be 0e100. Okay. Okay. So far, so good. I think now we'll go to the end and start crafting that signature. Okay. So edit. Nah. All right, so E4A1, E4A1. And 48107. Now, there are some tools to automate this process. I wanted to show you the manual way to do it, in case you had any questions. All right, I think that looks right. Now let me take the catalog blob and just stuff that to the end of the win certificate structure. And fingers crossed. Okay, so we've made progress. Now notice the status is hash mismatch. Okay? So this is the operating system working as it should, right? You can't just take a signature, apply it to your code, and it's automatically going to validate properly. Now, there's plenty of malware that does this. In fact, the most recent example I can think of was Bad Rabbit, where they took Mimikatz, and then they took one of the embedded Authenticode signatures from an old sysinternals utility and just applied it to Mimikatz, presumably to evade some security products. I don't really know, but at the end of the day, it's not going to validate properly, even though it will still kind of look like a Microsoft file. So our goal now is to take the hash mismatch status and make it valid. Okay, so this is the easy part. Okay, so here is the path to the SIP verification portion of the registry. And note, I don't know if you remember the GUID from before, but this is a GUID that is specific for PE validation. Okay? And all we're going to do is, instead of what was there before, which was wintrust.dll, and then like cryptsip DLL verify indirect data or something like that, we're going to hijack it with the DBGUI continue export function. That just like gives a thumbs up, returns true, basically. So I need to do this from an elevated prompt. Okay. Let's start up a new process. And we're good. Now, just to show you that I'm not cheating and that I'm not taking advantage of get Authenticode signature in PowerShell, let's look at it in SigCheck. Yeah, we're good. Signed, Microsoft. Now here's a tricky part. So digital signature in the Explorer UI shows it's not valid. So you would need to restart the Explorer process for the hijack to take effect. I'm not going to restart Explorer right now, but just take my word that once it's restarted, then it will be a perfectly valid signature from the context of Explorer. Okay? So, are there any questions about that process before I get into the next demo? So again, I crafted the win certificate blob. Now the easy thing to do would have been to just copy and paste the embedded authenticode signature in kernel32.dll to hello world1.exe. The choice is yours, really. Oh yeah, and I wanted to show you here. Okay, so hello world1, note the thumbprint value. Identical thumbprint value. Okay, so the reason that they match here is because I chose to attach the catalog signature as an embedded authenticode signature for Hello World 1. And because get authenticode signature defaults to catalog validation, then I have the match here. There would be a discrepancy in using SIGCheck because SIGCheck will go by the embedded authenticode signature thumbprint value. So we should, so again, well, I'll skip that part now, but just it's something you should be mindful of when you're performing these attacks. All right. So the next attack we're going to perform a certificate cloning and root CA installation attack. And basically the only goal with this attack is to exploit defender behaviors. So we're going to craft a code signing certificate chain that has the look and feel of a Microsoft certificate chain, as we could see here. So as a defender, if you were to look at helloworld.exe and see all of this, like that's going to check all the boxes for you mentally, right? So you can move on. Maybe aside from the fact that helloworld.exe is kind of weird, but I trust Microsoft as a reputable vendor to not ship malware to me. So let's move on. All right. We're going to dive right into the next demo. This one is a little more straightforward. So the first thing that we need to do to emulate the look and feel of a Microsoft certificate chain is to just go to a certificate chain. Let's look at, let's go to kernel 32 again. All right. View the certificates. And you can see the chain here. So I want to copy all three of those certificates, clone them, and sign each one along the way. And then at the end of the day, that Microsoft Windows Leaf certificate is what I can use to sign my malware. But then there will be one more step that's required after that, which I'll show you in a little bit. So the way you, one of the easy ways to save these off would be for each certificate in the chain, you go to details, copy to file, and then this UI will show up, and then you just copy them to disk as .cer files. So I've already done that ahead of time. I've copied all three in the chain. So I have kernel32 root.cer, the PCA, which is the issuing certificate of the Leaf certificate, and the Leaf certificate itself. Obviously, I don't have the signing keys for these, but all I'm going to do is just clone all of the fields that I can clone, which is basically all of them, more or less, except for the public-private key pair. I'm going to have my own key pair. Okay? So let's get started with that. So you call in PowerShell the get PFX certificate to get an X509 certificate object for the CER file. And then what you do is you take that certificate object and pass it to new self-signed certificate -clone cert. So this is a really handy commandlet here. And I'll do that for each certificate in the chain. Now, all root CAs are technically self-signed. Like because they're a root certificate, there is nothing besides themselves to sign it. So our cloned root certificate will be self-signed, but we're then going to trust it later on. Every other certificate in the chain has to be signed by the next level up. So here, in the case of the PCA cert, that needs to be, its signer will be the root CA. So here we're building out the signed cloned certificate chain until we get to the leaf certificate. So let's clone these bad boys. And what's kind of cool about this attack is that I don't have to do any of this in an admin context. Okay, so we have 3 cloned certificates now. Let's look at Hello World 2 this time. Validate, it should not be signed currently. Now let's sign it with our leaf certificate, our cloned leaf certificate. Okay, so it looks like it's signed, only the status returned an unknown error. So let's get some more context about what that error might mean. Okay, certificate chain processed but terminated in a root certificate which is not trusted by the trust provider. So our cloned root certificate is not explicitly trusted. This is one of the steps that is required for certificate and digital signature validation, is that the root certificate that issued all the subsequent certificates is actually trusted. And let's look at some of the details of the signature here. I mean, this kind of has the look and feel, right, of a Microsoft certificate. Only we have that error. So let's take the unknown error and change it to valid again. Okay, so what we're going to do is we're going to just export the cloned root certificate, save it to disk, and then import it into the root CA store. And this can be done, again, I'm not admin, and the only thing you'll see is this prompt. And yeah, of course I trust it. Okay, so I've now trusted it. And now this is another case where you probably need to restart the process. And sure enough, we're good. So completely valid certificates, the look and feel of Microsoft. And I've been using get authenticode signature in PowerShell a lot. Again, there's going to be no difference in the validity of the certificate, whether it's get authenticode signature versus SigCheck versus Explorer versus any of the sysinternals tools. It all goes through the common SIP infrastructure that's abstracted away from the signature validation utility, and it's all going to look the same. So just wrapping up, I have some pretty extensive references on the subject. So the first attack that you saw, the SIP hijack, I have a really lengthy white paper that goes into very explicit detail about the signing the user mode signing infrastructure in Windows, and how to perform the SIP hijack attack in addition to a trust provider hijack attack. So it's all in there. And then I've got a blog post dealing with the code signing certificate cloning attack, as well as prevention and detection steps for that attack. So after having seen both of these attacks in action, has your trust changed even a little bit in how code signing is performed in the operating system? So as a defender, you really should be mindful of this and acknowledge that this is clearly in the hands of an attacker now. If an attacker just wants to emulate the look and feel and they don't happen to be an admin, they can do the certificate cloning attack. If they are running elevated, then they also have the option of doing the SIP hijack attack as well. And as I've said many times, pretty much all of the tools out there I consider to be insufficient in determining the trustworthiness of the signature that was used to sign, in our case, malicious code. And ultimately, the way that you would validate that trust is by that thumbprint value. So number one, so in the certificate cloning attack, that had a unique thumbprint value that chained to a root certificate that had its own thumbprint value that has no business being trusted. And Microsoft actually publishes a list of trusted root CAs and all of their thumbprint hashes in the form of its authroot.stl. And in the blog post, there's a link to that where you can go download that and validate what should be a trusted root certificate versus what shouldn't be. And then so you could presumably use that to like sweep your environment to audit your root certificates. So that's all I have. I think we have a few minutes for questions. So thank you.
Second attack, how do you get the victim to import the fake root CA?
Yeah, that's a good question. So how do you get the victim to import the root CA? So I haven't discovered a way from a non-admin context to import the certificate without the UI prompting. So I would love to see you guys maybe investigate that, because all of this is just stored in the registry. But there's a very specific ACL set on the user-specific certificate blobs in the registry. So like if you just try to set it directly, it'll just wipe it clean and like it won't actually persist in the registry. If you're doing the certificate cloning attack as an admin, then you can just, you can form your chain and then just get the blob and just stuff it directly into the registry. So that's one option. And if you're already admin anyway and like you have credentials, then like you could just use, for example, like WMI to just stuff that in directly via the STD regprov WMI provider.
Thanks, Matt.
Yeah.
Going on the previous question, I was quite surprised to see that you can import trusted root certificates as an unprivileged user at all.
I know.
Do you know Microsoft's stance on this? I was surprised. I would, if you'd asked me before, like, can an unprivileged user do that, I might have responded.
Yeah, I mean,
so
I believe a non-admin user has absolutely no business
right.
being able to trust their own root certificates. It could be a convenience thing, like let's say you're a developer and like you want to run Fiddler, right? So like you need to install that root CA to hijack SSL, right? But ultimately, like I don't think you should be able to do that in an enterprise. There's a registry key you can set to prevent that
That
user mode trust.
Is there an easy way to prevent that?
It's in the blog post.
Okay,
Yep.
thank you.
Yep.